Welcome back. Today we're going to talk about some more exponent rules and expressions involving variables. So for our exponent rules, there's the product, power of a product and the power of a quotient that I'm going to go over today. So for all real numbers A and rational numbers C. So we looked at exponents that were rational numbers C, and for real numbers as the base of this expression here. If you have a product and you're raising it to a power, so if you have a product here, two factors that you're multiplying, you're raising it to a power, then you can just take the power and apply it to each of the factors and then multiply the factors together. Okay, so it's sort of like an order of operations. Here, I would multiply first and then raise the power. Here, I'm going to raise the power first and then I'm going to multiply together. What this property is saying is that each of these is equivalent. It doesn't matter which one you do first. Okay, as long as you raise each of the factors to the same power. So an example of this would be like, x times y to the second power. Well, what does that mean? That just means x y times x y. By the associative property of multiplication, I can drop the parentheses. By the commutative property of multiplication, I can rewrite it so that the factors are next to each other, and then I can rewrite it in exponential form here. So what just happened? Well, look at the exponent. You can just bring the exponent into each of the factors that you have in a product. So the power of a product is actually just the product of two powers. It's another way of saying this rule. And also, it doesn't matter if you had, let's say that you had three things that you're multiplying, A, B, and I don't know, F. Raising it to the C power, it would just be A to the C power times B to the C power times F to the C power. This works for any amount of factors inside. So each of the factors gets raised to the power that you are interested in, and then you could just multiply them together. This works really well when you have expressions involving variables where you can't actually multiply the variables together, so you're going to have to simplify using the power of a product rule. Likewise, the quotient, power of a quotient, if you have a quotient that looks like a fraction, right, and it's raised to a power, you can just take the exponent and apply it to the numerator and the denominator, okay? You can also, if you see a quotient that's been raised to the same power, you can write the quotient, so you can actually rewrite it the other way around. So what's nice about this property is that it goes either way, right? That these forms are equivalent. So if you started on this side and you saw that you had a quotient and it had the same power, you can always rewrite it as a quotient like this with the same power. Okay, let's talk about expressions. Exponent rules apply to expressions with variables, which we haven't talked about. So I'm giving you all variables here. I'm not giving you numbers as basis. I'm giving you variables. Now, sometimes the book will say, like, let x comma y be real numbers. Now, it's not telling you to actually put real numbers in for x and y. This is just saying that if x and y were real numbers, then what can you do? And this all goes back to this last page when we said that a and b, this property works when these are real numbers, okay? So it's saying, okay, we're in the set of real numbers. So if x and y are real numbers, then we know that the properties hold. That's all that's saying. It's not saying substitute x and y in for real numbers. Okay, well, the product of powers means that these two things, you have actually this is two, well, no, it's not the rule that we just saw. This is the product of two powers. So this is the product of, these are all products of powers, right? So this is the product in between the parentheses, as indicated by the parentheses next to each other. And then within the parentheses, there's multiplication. Because remember, when you have variables, when variables are next to each other, the multiplication is implied, okay? So what you can do by the associative property is you can take off the parentheses. If everything's being multiplied, then you can just take off the parentheses. That's just x squared y squared times x to the fourth, y to the eighth. But really what that is, by the commutative property, we can write these next to each other. Whoops, I put y to the eighth, but it doesn't really matter. There's y squared right there. This y squared became this y squared right here. Let me get another color. Now, x squared times x to the fourth, we were told to keep the base and add the exponents, okay? Y to the eighth times y squared would be keep the base, and add the exponents. And that's as simplified as you can get it. You cannot combine x and y together, okay? Okay, so the quotient of powers, remember the quotient of powers said if the bases are the same, we can keep the base and subtract the exponents. So here we're going to combine the bases of x and then similarly combine the bases of y. So here we have x to the 4 minus 2, oops, that's a 4 there, times y to the 3 minus 6. Well, that's x squared times y to the negative 3. Now, often we do not leave a negative in our answer. In fact, let's just say that that is always the rule. Do not leave a negative exponent in your answer. We're going to have to rewrite that as x squared times 1 over y cubed, which is, okay, let's put x over 1. We'd multiply this out like this. This ends up being x squared over y cubed. So if you have a I don't mean to draw a box around here, but if you have a product where you have a negative exponent, what ends up happening is the factor that doesn't have a negative exponent ends up being the numerator, and then the factor that has a negative exponent ends up being in the denominator, but you make the, whoops, that should be y cubed there. But the factor that had the negative exponent ends up being in the denominator. So that's the answer to that problem. Okay, raising a power to another power, we keep the base and we multiply the exponents. So that's our answer right there. Okay, if we have a negative exponent, so this is a combination of rules. We're going to do the, so you have a product inside and we're taking the power of it. So we're going to use the power of a product rule, which means we're going to take the exponent and apply it inside, just like that. So we have x to the negative 2 times y to the negative 2. Well, x to the negative 2 is just 1 over x squared times 1 over y squared, which would be equal to 1 over x squared y squared. Okay. Likewise, we actually could have applied the negative exponent rule first, which says that you have 1 over x y quantity squared. This is just an alternate way of doing this, which is equal to 1 over, and now you can apply the power of a product rule. You have x squared over y squared because you're bringing that exponent of 2 in. Okay, same answer in the end. Doesn't matter which rule you apply first. Okay, likewise, if you have a zero exponent, now I said that, so you're having your two variables that are adding together. The only thing that you cannot, so a to the 0 power is equal to 1 as long as a is not 0. Oops. A is not equal to 0. Well, something that's, you can't have x and y equal to, actually you can't have x equal to the opposite of y, really. Because think about it, if you have 3 plus negative 3, for instance, if they were opposites, then that would be equal to 0, and what you'd be trying to do is put 0 to the 0 power. And so as long as a is not equal to the opposite, or x is not equal to the opposite of y, this is just 1. Okay? Okay, let's do the product, power of a product rule. So if you have, inside here we have a monomial, so it's 3 times a squared times b to the 4th. We're going to take that 4 and apply it to all of the parts of the monomial. So here we have 3 to the 4th times a squared to the 4th times b to the 4th raised to the 4th power. Okay, and these are, my 4's end up looking like 9's here, so let me just go back and correct here. This is 4 and this is also 4 and 4 here. So here 3 to the 4th power is 81, so I'm going to actually evaluate that, and then we have a to the 8th power and b to the 16th power because we're using our power of power rule. Okay, so the first thing you do when you're raising a monomial to a power is you write them, all the factors separately raised to that power. Okay, likewise here we have negative 3, careful to put it in parentheses, we have negative 3 cubed times a cubed cubed times b cubed. Okay, now this would be negative 27, b to the 9th, I'm sorry, a to the 9th and b to the 3rd. Okay, that's application of product of powers rule, or power of a product rather. And so power of a product allowed us to make from this step, and then power of a power rule allowed us to go to rewrite the a as a to the 9th. Okay, here we have 9 squared and x squared and y squared. So this just ends up being 81 x squared y squared. Okay, now with the quotient, all we have to do is take the exponent and apply it to both numerator and denominator. Here it's a little bit more complicated because what you want to do, the numerator is itself a product. So the first thing you do is take the numerator, separate it, and apply the 6th power to it. Take the denominator, separate it, and apply the 6th power to it. So that's the quotient of power of a quotient rule. Now we're going to use power of a product rule by bringing each of the 6 inside to each of the factors. The exponent of 6 inside to each of the factors. So we have x squared y to the 5th. Oops, that should be to the 6th power. X should be to the 6th power. To the 6th power. Y to the 5th to the 6th power. Z squared to the 6th power, all over x to the 4th to the 6th power, y to the 3rd to the 6th power, and z to the 6th power. Okay, so let's simplify this. We have x to the 6th power, y to the 30th, z to the 12th. Okay, then we have x to the 24th, y to the, let's see, that's y to the 18th, and z to the 6th power. Now we're not finished yet because we have like bases in the numerator and denominator. So let's go ahead and subtract, keep the base, x, and then 6 minus 24 is negative 18. We have y to the 30 minus 18, which is 12, and then we have z to the 12 minus 6, which is 6. Okay. Now we're not finished because we have a negative exponent, so we want to put that in the denominator of a fraction, right? This one will become positive in the denominator, and then we have y to the 12th, z to the 6th power. All right, so we used almost every rule here. We used power of a quotient, we used a power of a product, we used power of powers, we used quotient of powers, we used negative exponent. So there's a lot of rules we use for just this problem. All right. And that's the end of the lesson for today. Thanks.